Hey 7th grade. In this next lesson, our goal is to learn how to describe linear functions using equations. And so we know, of course, already that a linear function is an equation whose graph is going to give you a line. And so in the last video, we practiced looking at lines and describing the slopes of those lines, and also looking at 2 points on a line and using our slope formula to calculate the slope of that line. Today, we're going to be focusing more on how to describe a line using an equation. Okay, and I just want to review first of all how you know an equation is a linear function versus a nonlinear function. So one thing you'll recall from our last unit over function families is that you'll never see exponents on the variable in a linear equation. Okay, so you won't have any x squares or x cubes in a linear function. So just some examples of linear equations versus nonlinear equations. If you had the equation y equals 2x plus 5, that would be considered linear because, again, you don't see any exponents on the variables here. The equation y equals x squared would not be linear because of that exponent there. That'd actually be a quadratic, and that's a function family we'll be looking at more in depth at the end of the year. You can also have equations in function notation form. F of x equals, and you can have fractions in your equations. So f of x equals 3/5 x plus 4 would be a linear equation. Again, no exponents on the variables. But if you had an equation like this, f of x equals 2x cubed plus x plus 1, that would be nonlinear, again, because you've got that exponent there on the x cubed. Okay, so that's just a review of how you tell whether an equation is linear versus nonlinear in the first place. And again, as I've been saying, this entire unit is going to be devoted to the linear functions, and we're going to be focusing on those for this unit. One vocabulary term that I want to define starting in this lesson, this will be something we'll be coming back to from now on over the next couple of years, is the term y-intercept. What we mean by y-intercept is the y-coordinate of the point where a graph crosses the y-axis. Okay, so that phrase y-intercept will be coming up time and time again, and it's something that's going to come up a lot in this lesson in particular. And what you need to remember is that it's the y-coordinate of the point wherever a graph crosses the y-axis. Okay, so that brings us to our main concept for today, which is this. If you know the slope of a line, okay, which is what we practiced doing in the last video, and you also know its y-intercept, which again is the y-coordinate of the point where the line crosses the y-axis, then you can write the equation of that line. And there are actually many different forms for equations of lines. We're going to focus on the most basic one today, and this is one that you've seen before. This is called Slope-Intercept Form. We've not actually assigned a name to this before, but if you look down here below, it's going to look pretty familiar to you. Y equals mx plus b. This is the most basic, as I said, form for a line, and this actually has a name, Slope-Intercept Form, and it's named that because it tells you two things just by looking at the equation. It tells you what the slope is and what the y-intercept is. So in the last video, I introduced you to this concept of m representing slope, so you'll notice there's an m in this equation right here. Okay, that m is the coefficient on x, and whatever that number m is, that's going to tell you the slope of the line. Okay, so the m value is the slope of the line, and then we have this b value here. That b value actually tells you what the y-intercept of the line is. Okay, so if you have an equation in y equals mx plus b form, m will tell you the slope and b will tell you the y-intercept. So now we're going to look at a few examples of equations in slope-intercept form, and we're just going to practice identifying what the slope is and what the y-intercept is on each of these lines. So number one, we have y equals 5x minus 2. And so if I were going to graph this line here, which we'll learn how to do later on in the unit, I want to know what would the slope of the line be and where would the line cross the y-axis. Okay, well, again, slope-intercept form is this, y equals mx plus b form. Okay, so based on where these numbers are, we know that the 5 is actually our m value for this form. So my m value is equal to 5. My b value, would be the constant, -2. Okay, so b is equal to -2. That means that the slope of my line is +5, and the y-intercept of my line is the point 0, -2. Now it may be asking, why am I saying that the point is 0, -2? Well, it's important to remember that the y-intercept, again, is the point where a line crosses the y-axis. Anytime you have a point on the y-axis, remember the x value is equivalent to 0. So y-intercepts will always have an x-coordinate of 0, okay, if you think about where they are on the coordinate plane. Okay, for number 2, we have y equals x plus 2/3. So again, slope-intercept form is y equals mx plus b. This equation here is in slope-intercept form. The m value in this case is the coefficient on the x, and since there's no number written in front of x, that means there's a invisible 1 in front of that x. Okay, so my m value in this case is equal to +1, which means my slope is +1. My b value is the constant 2/3. Okay. Y-intercepts can also be fractions, but just remember the y-intercept, unlike the slope, okay, the slope is a rate of change, the y-intercept is an actual point. So we're not going to say just 2/3, we're going to say the point 0, 2/3. Okay, and then finally number 3, we have y equals -1/2 x. This is also in the form y equals mx plus b. In this case, the m value is going to be -1/2, which is also your slope. The b value in this case is sort of hidden. There's no constant at the end, so we can imagine there's a +0 there. So that means my b value is 0, and so my y-intercept for this one would actually be the point 0, 0, or the origin. So this line would be crossing at the origin. Okay, so that's how you identify slope and y-intercept when you're given an equation in slope-intercept form. Now in examples 4 and 5, we're going to do the opposite. This time I'm going to give you the slope and the y-intercept, and you're going to write the equation. So number 4, I'm telling you that the slope is, or the m value is -4/5, and the b value is 7. So to write an equation in slope-intercept form, you need to have it in this format, y equals mx plus b. So we're just going to plug in this m value of -4/5 for m down here, and this b value of 7 right here, and you're going to get the equation y equals -4/5 x, don't forget your x there, plus 7. For number 5, we're going to do the same exact thing. We just need to remember that slope is the m value, and then the y-coordinate of your y-intercept, which is -1, is your b value. So this equation would be y equals 3/2 x. B value is a -1, so this would be -1. Okay, finally the last two examples, we're going to do exactly what we did in 1 through 3, except this time instead of giving you an equation, I've given you a line. Okay, so we want to write an equation in slope-intercept form. That means we need to know what is the m value and what is the b value. Okay, well we already know how to find the slope given a graph of a line. We practiced this in the last video. So for number 6, I'm going to take this line that I'm given. I'm going to locate 2 points on the line. Okay, I'm going to locate this point right here, and then this point right here. Again, you can pick any other 2 points on the line, and I'm going to calculate the rise over the run. Okay, so if I start on the bottom point, I need to go up 1, 2, 3, 4 spaces to get to my top point. So that means I have a rise of +4. And my run, I need to go to the right. So that means I also have a positive direction, 2 spaces to get to my other point. So +2 for my run. So that means my slope is +4 over +2, which reduces to +2. Okay, I also need to find what my y-intercept is, my b value. Well, I've already identified where the line is crossing the y-axis. It was this bottom point here that I highlighted. This is where the line intersects the y-axis, and that point right there is the point 0, 1. So that means that my y-intercept is actually +1. That's my b value. So if I want to write an equation in slope-intercept form, y equals mx plus b, I can say that that equation would be y equals my m value 2x plus my b value 1. I'll do a similar thing for number 7. I'm going to locate 2 points for this one. The first point I'm going to locate is going to be my y-intercept. So that's the point 0, 4. So that right there tells me that my b value is going to be equal to positive 4. Now I just need to find my m value, so I need to calculate my rise over my run. To do that, I need a second point on my line. I'll go ahead and I'll pick, let's see, this point right here. And now I'll calculate my rise over my run. So if I start with the top point, I need to go down 2 spaces, so that's going to be a negative direction. So my rise is negative 2. And then for my run, I need to move to the right 1, 2, 3, 4 spaces. That's a positive direction. So my run is positive 4. So we have negative 2 over positive 4. That's going to reduce to negative 1/2. So your m value is negative 1/2. And now to write the equation in slope-intercept form, that's going to give us y equals negative 1/2 x plus 4. Okay, as always, if you had any questions while watching this video, be sure to jot those down or email me. And until I see you the next time, have a nice day. You're all wonderful people. Take care.